because the moon is an airless body, there's nothing to slow down the dust. And here on the Earth, if you took a handful of gravel and sand and, let's say, baby powder, talcum powder, and throw it, what you'll see is the rocks go the farthest, the sand goes intermediate distances, and the dust just stops as soon as you let go. And that's because they have different ballistic coefficients. It's the ratio of the inertial force to the atmospheric drag force. Well, on the Earth, the atmospheric drag is slowing things down, but on the moon, there is no atmosphere except for the rocket exhaust. And the rocket exhaust is what's speeding everything up. And so it speeds everything up, and then all that material flies out into vacuum, and there's nothing to slow it down. And because the drag force is more dominant on dust than it is on rocks, it turns out that on the moon, the dust goes the fastest and the farthest. The sand still goes intermediate, and the rocks go the shortest. And the rocket exhaust is traveling at about in the ballpark of 3 kilometers per second. And there are dust particles that are small enough that they get all the way up to the speed of the gas. And so we're blowing dust at about 6 times the speed of a bullet, and it causes huge abrasion and sandblasting damage. It can ruin telescopes or solar panels or thermal control surfaces. It can get into mechanisms and jam the mechanisms. Because the thermal control getting etched by the dust, it can cause the electronics to overheat, have a higher mean time between failure, causing them to fail. And so it is a big problem. Also, here on the Earth, when we have a blast, the effects of the blast are localized because the rocks get sped up the slowest, but they're the ones that travel the farthest. The dust also gets initially sped up the fastest, but it gets stopped immediately. And so that localizes the radius of the blast. But on the moon with no atmosphere, there is nothing to localize it. So every blast on the moon is a global event. As long as the rocket is large enough to speed the dust up to the velocity of the rocket exhaust, then the dust goes globally around the moon. And the only way we can mitigate it is by determining how much damage is acceptable and land that far away or build landing pads or some other technology.
Who answers that question?
It has not been answered yet, and that's a geopolitical issue.
Well, yeah. The effects of just one launch would be, is catastrophic the right word? Like, what's the word to describe what would happen to the lunar surface for a layman, not a scientist?
It depends on a lot of variables. It depends on the size of the lander, because the amount of gas they blow is proportional to the weight of the vehicle. And also it depends on how high the engines are above the lunar surface. So if Starship uses those upper thrusters, that will greatly reduce the problem, not entirely stop it, but it will greatly reduce it. So it also depends on how close your hardware is, other hardware around the landing site. So there's a lot of variables involved. It could be catastrophic for some hardware. If you land too close to some sensitive equipment, you could possibly damage it or destroy it in just one sandblasting event. But typically it's more of a problem where you're wearing the hardware, and over time, the hardware will eventually fail much sooner than originally planned.
Kind of like mechanical electrical systems near the ocean.
Yeah, that's a good analogy. Right. Yeah, like I was doing some analysis where I estimated if you have a 40-ton lander and it lands 1 kilometer away from an antenna on the moon, then after 10 launches and landings, the amount of dust blown into those joints from 1 kilometer away, the amount of dust blown into those cracks will cause the antennas to jam so they can't rotate anymore. Now, that's a very crude estimate because we don't have enough data yet, but that's the order of magnitude that we're looking at. Now, I mentioned earlier sensitive hardware. If you have a sensor that is on a lunar lander and it's going to go up into orbit and it's going to measure something on the lunar surface, let's say this instrument needs to have a resolution of 3 meters per pixel. One sandblasting of that lunar lander of the instrument on that lander could ruin it so that it's no longer able to get the required resolution to produce better than existing data sets. So it could be destroyed in just one exposure.